This time I'm not going to work on the compiler directly, but I want to do some changes to the build system. Currently for building I'm using Rake. This is a task runner for Ruby, and Rake has also file tasks that can be used to compile single source files. But the problem that I have with Rake, if Rake has a lot of tasks and some dependencies, it's getting pretty slow because of how metaprogramming in Ruby works. So I want to move the compilation tasks itself into another build system called Ninja Build, and just see whether the compilation gets faster. So for example, if I execute Rake now, even if I haven't changed anything, then it takes some time, so a few seconds to finish, and we compile very often, and yeah, it's a bit slow. I'm not going to write, I think, Ninja build files by hand. I still will generate them with Rake, but these files need to be generated only if we have some changes into the compile flags, or if I add a new stage, which doesn't happen very often. I don't remember that well how Ninja works, so we will look into the documentation and just see how it goes, I suppose. So if I execute Ninja, it says that it doesn't find build Ninja file. We can create one. I'll try to write some tasks by hand and just to see how it works, and then yeah, try to generate this file. So if I execute Ninja again, it says no work to do. I have the documentation, so it is Ninja manual in the second into the second tab in the second tab, and I will consult this documentation permanently. Yeah, my compiler is a multi-stage compiler, so if I do Rake clean and clear all build materials and execute Rake, then it compiles beginning with the stage 1 and so forth. And we have currently 18 stages, I think. And stage is like a compiler version, so each following stage understands more features, and each stage compiles to the next stage, and so the compiler gets more and more features. And the first stage is basically written in assembly, and the following stages are moving far and far away from the assembly in the direction of the programming language that I target, that is Elna. Yeah. So we will try to write some rules by hand, just to get taste of Ninja build. And the last command that is basically executed, this is the linker, so it gets some flags, and and outputs the result into this build valid stage 18 CL file, so it is the final executable. So let me copy this command and insert in here. So the documentation has this syntax example section, and it has this build statement in here. So this is how a build statement looks. It has the target file after the build command, and then the compilation command follows. So we write build, and the file that we are building is this one, and then colon, and it actually should be enough. It is still won't work since we do not specify any, so it want to have a build rule. It cannot just execute a random command. Okay, the rules are written this way, so we just add a rule. Let us call it LD, and command is, and then let us just call it is LD, and then try again. Expected command equals, I think it doesn't like tabs. Okay, good to know. Yeah, now it says that it wants to have a default target. Exactly, default target statements by default, if no target is specified in the command line, Ninja will build every output that is not named as an input elsewhere. And here it says default foo, for example. That would mean that I would suppose that it is called then default dependency cycle. Because it can see, of course, that this file is a dependency, so we need to replace it with a variable. So let us go back in the documentation, and this is this out variable that we have to use, I think. Oh, they're used in the commands and not in the build statement itself. So let us move it away from here into the command and try to execute Ninja. Dynamic linker needed by missing or known rule to make it. Okay. Basically wants that we copy all the flags. We probably haven't to move this stuff like shared library references and so forth, since they exist on the file system and Ninja should be able to find them, but we can copy them into the command so that our build statements are shorter. So here we have the input file. I'll C, and after that goes the input file, and then we link the last object file. It will now complain that it can find CLO. So let us try it. Yes, the compilation works now. Let us rename this comment, we call it link. So let us now remove again some build artifacts. We remove the stage 18 and just call rake. So we have this command. We want to also have this command. So we compile an assembly file outputted by our compiler, and we compile it into an object file with GCC. We need another rule for the compiler. I probably will call it assembler is the canonic name, and we will add a comment here, and we will call GCC. This is, let us copy the comment once again, and this is the output file, I suppose, and this is the input file. Now we create a build command here and call it so this is the target. Our target is this object file, and we call the assembler. We can remove the flags, and our dependency is only the assembly file in the same directory. We will put it before the linking command, and we will try to call ninja, and it seems to work as well. If I call it second time, it says that there is no work to do. So now we compile the object file, and the next step would be to produce the assembly. To produce the assembly, we need our compiler itself. These files that are generated in the valid directory, this is the validation step. So first, the previous stage of the compiler compiles to the next stage, and this next stage compiles itself then. I just validate that the new stage works this way, and it was pretty useful in past to detect compilation errors. And therefore, we need the current stage compiler to produce the assembly file. It will be a bit more difficult, I think, since I do not pass the source file as a comment argument, but I print it into the stdin or the compiler. So compiler reads the file, the source file from the standard input, and outputs it into the standard output. Honestly, I have no idea how Ninja works with standard streams. So basically the thing that we need is, if we look into build valid stage 18, this is the final file, object file, and assembly file. To build the assembly file, we need the compiler from the boot stage, and this is this one. So I also do not know. I think I probably have to define a rule for each stage. Which won't work since I do not have or probably it will. I just can generate the rules for all stages. It doesn't matter if the binary doesn't exist until it is used. So we need a compiler rule with some comment, and we need a new build statement. So this is the source actually, so this is the comment. In build boot station 18 CL, and our the file that we want to produce is this assembly file. This is our target, and we use the compiler for it. I wonder if I can just use shell here. If this is the case, I can just read the source file into input. So let us try it with cat first. So we read the input file and out and get its contents into the compiler, and then we save the output in the out file. And the input for this compiler is the source file for the stage. The source file for the stage is source it was stage 18, I think. No, I'm pretty sure it is nonsense. Boot stage 18, yeah. CL.elna. So yes, it seems to work. I'm pretty bad at shell. I think something like this could be possible. Yes, it seems it is possible. And if I remove the stage completely, so valid stage 18, we can compile all the files already. If I remove this thing, then I probably should be able to produce everything. And if I look into build valid stage 18, then we have all the files there. So it does seem to work. The only thing I'm not happy about is basically this this rule command. Another possibility would be probably to generate a Ninja file for each stage. Yeah, we can move flags into variables. But we do not have a lot of flags. Okay, we have here some flags for the GCC. We can actually really define just C flags is position independent thing, generate debug code, and C is probably not a generic file, not a generic flag, and then we can write here C flags. And the linker flags, but the most things, so it points to the dynamic linker and links the C runtime, and the input file should be between LC is actually a linker flag that can be used probably. Yeah, nothing to do. Okay. So it has also a dep file. We do not have a lot of dependencies. Everything is in a single file, since we do not support modules yet. Pools allows you to allocate one or more roles or ages, a finite of concurrent jobs, which is most like this. This is not interesting at all. Here are the descriptions of variables, I think. So dep file, comment, deps, if present, must be one of GCC or Microsoft Visual C, special dependency processing, see the full discussion. Deps prefix description, dep available since usually only on build statements. If present, must name one of the build statement inputs. Dynamically discovered dependency information will be loaded from the file. Generate if present specifies that the rule is used to reinvoke the generator program files built using generator rules. Are iterated in two ways. Firstly, they will not be rebuilt with the command line changes, and secondly, they are not cleaned by default in new line, out, restart. Okay, and that is the end of the documentation. So let us go to the beginning once again. So we were by the syntax example. There are environment variables. I probably should just write an additional code for the stage, so we can just look how it how it is done. Yeah, let us rename it into valid 18, I suppose. No, it is not the validation compiler, it is the boot compiler. Let us call it boot 18. And we need the compiler from the previous stage. It will be rule valid 17, and this compiler is then in valid state 17cl. The command remains as it is, and we do almost the same stuff. So I'll just try if it still compiles. It doesn't want to do anything. Then we just copy these three build statements and we paste them in here, but we do not compile the validation stage, but we compile the boot stage. Everything else remains as it is. We will actually need 2 link commands. There were files in the first stages of the compiler. I haven't used the standard library, so some flags were missing. So we compile the boot stage here and the first thing that we need is to build the assembly. For that we need the previous stage compiler. So this is valid 17. Its input is still this source file. Then we get the assembly. We can compile this assembly file. So boot stage 18 assembly. We can compile it and write into the object file, and then we link this object file with the standard library and get in the final compiler, and then we use this compiler to do the validation. And actually we probably, if it works, we can use this indirect dependencies to say Ninja that the binary should be compiled as well, because this stage probably doesn't know that it depends on this line. Nothing to do. Build valid stage 18 can be removed completely, and I think that the boot stage can be also removed because we actually generated. So stage 18 can be removed completely. We only need the validation compiler from the stage 17, so this one can be removed. And then we do Ninja, and it doesn't work, of course. Line.cl, no such file or directory. Because it doesn't know that it will be generated later. Stage 17cl. We actually have a rule for this compiler, but Ninja checks the commands in the beginning. I can probably use something like exec. such file directory still. And if I put a dependency on it, so here we need the boot 18 compiler. That means that we depend on this thing here. And this works then that way. Okay. So we just need to pass the dependency and say that this is an implicit. I think it called it something dependency. So we need to tell Ninja that the compilation depends on this file. Do I really need to write these comments each time? This is a bit tedious. Yeah. And we can basically use the same thing in here, but this thing will depend on this validation stage compiler, I think. Yes, exactly, on build valid stage 17 CL, but otherwise it shouldn't be a problem. Let us. No, it won't work probably. So build boot stage 18 CL in and out. Basically in is what I have and out. No, I think it is nonsense. Okay, this is enough, I suppose. So now we go to the reg file. What tasks do we have? We have this boot task, and this boot task is the default task. We have convert task, then we have some rules, and we have code that checks all the stages, and then we have a task that generates documentation. So let us create a build task. Build. And we will just generate this Ninja file assist first. So basically file write. We copy this thing and paste it in here. Okay, that means that if I now remove this file, then it can be regenerated. No. Oh, build is a directory and it probably thinks that it is a file task. Let us call it, what do I know, Ninja. Yes, that definitely looks better. And now the file is generated. Yes. Actually, it can be a file task. Now, when I think about it, I actually generate a single file. So we can just say that is a file task that generates this build Ninja file. Ninja. Build Ninja file. And we get the contents and write it into this file. We actually can have an argument here, t, and the input. So this is the t source. The another one was t prerequisites that were the dependencies, but we need this target. Oh, t name. This is the task name. Exactly. So we just say that this is the t name, and then we can just say that we want to generate build Ninja, and Rake should be able to do so. We can also add some dependencies. I won't keep this file into the root directory, but into the build directory, and we can just say that the file depends on the existence of the build directory. So now let us think. This header should be always where. This header should be always there, so it is constant. No, actually, the linker comment will be generated as well. But let us, if I generate all stages, it won't work. So actually, I think that this is constant, but let us begin here. And the other things are generated dynamically. So let us just then glob all the files into boot. I actually do it something, but somewhere, but I want to make it dynamically, so I do dir glob on this directory. This probably won't harm, and I can just output the stages here. Nonsense. So we need reg build Ninja, and it does nothing because the file already exists and is up to date. So here we collect all the stages, we take the base name, it isn't actually run. We can just get this status variable, I can move it later into the function itself. so let it be, we just use the stages each. And then we have each stage I can just I will generate a variable first, but we need to write it into the file at the end, so we can just open the file and write it part by part. And first we need to generate these rules basically, so we generate 2 rules for each stage except the first one and the last one, I think, as well. Let us create a variable named footer, and we put this content in this variable, and at the end we just say header plus footer so that we can write this stuff in here. Then we have each stages, and we add an additional variable probably called contents. It's empty first. Yeah. And the first, so let us remove the linear again, just that I see what the stages look like. So we need the stage number. Let us add variable stage number and say that this is stage with delete prefix stage, and then convert it to an integer. Okay, and now we can add to our contents variable another string, and this string is 2 spaces rule, probably a new line first. A rule is actually the beginning, so we do not need spaces here, but it is a rule. Then we say that it is valid, for example, and we write the stage number in here. And we write the stage number in here, rule valid stage number, then we have a new line, 2 spaces, then a comment. And the comment is, so the validation stage is compiled with this, with the same stage compiler. No nonsense, this is just the validation stage compiler binary. So stage number as well, and then CL and in and out, and then we want to write a new line. So then we are going to write this contents variable in the middle. And it generates basically these valid comments, and it uses the validation compiler of the same stage. looks fine, but we do not have this valid 17 anymore at the end. So we can remove this one, I suppose. So let us remove this file again and then call rake build ninja and then called ninja itself. This could actually work, dependent on whether ninja checks the rules. Let us remove this the 18th stage again. So there is this build valid stage 18 and just check whether we can compile it. Yes, we can. So we go back to the rake file and then we generate the second rule. So the second rule is actually almost the same, and the difference being that we generate the rule for the Bootstrap compiler. The stage remains the same, but the binary is in build boot stage number CL. It won't be valid for the last stage, but it doesn't matter. We probably just want to use one rule. Actually, in rake, I do an additional validation step at the end. I compare the output of validation and bootstrap stage. They should be the same, and in this case, we can actually use the rule for the last stage, but I do not know whether I can. Probably I can put into the Ninja build file itself this check. Where was it? Where I was? It's actually already done. We can just remove this thing here and then try to remove the build ninja file and the build boot stage 18 and build valid stage 18, and then we can try to regenerate the build file. And then we call ninja and it compiles. Okay. And now we need to write the rules itself. Contents plus ninja and ninja at the end, and then we can just copy it probably, and I need the previous stage. I need the validation compiler from the previous stage. Yeah, let us copy this thing then and indent it, and then we replace just 18 with the stage number, stage number, and on the right side as well. And then here. And I think that Ruby did you mean console size? It seems that Ruby isn't installed properly. Can I execute something here? No such file directory. Is it E? Yeah. I think that there was predecessor. Yeah. So I got the rec file, and for some stages I use then stage number parent, and here stage number parent as well. So So 17 wasn't here, then 18 and 17, it was the only place, I think. Does this convert private stage? Okay. Yeah, that looks fine. So let us remove this footer then. And we just call rec.ninja. Yeah, that looks more or less fine. I think I want to go twice through the stages. So and I need the numbers each time. Yeah, we just do it twice. So first we generate the rules, and after that we generate the build statements. Okay, first are the rules generated, and then the build statements. So an additional new line wouldn't be bad, and we actually need a footer, but we can write it just in line in here. This footer is default build valid stage 18 CL. Probably with a new line as well. Okay, that looks fine. Unknown build rule valid 1. This is actually correct. Build valid stage 1. We do have stage 1 here, and it has only the compiler. So it goes also into the header, and basically we generate a rule like this at the top, and it will be valid 1 with the command stage 1 CL unexpected end of line, end of file. Default. There's unexpected end of file. Let's start CL. Okay, it wants to have an additional new line at the end, and then it actually compiles, but it probably undefined reference to main because I defined the start function before, so two things. The first one, that we need a new line at the end of the file, and yes, now I see it. We do not have a new line here. What else? So in each stage I have an additional file, and this file determines how do we how the linker is invoked. Yeah, this is basically this linker arg file, and if the file exists, then I use different linker rules. So basically a dynamic linker and all the flags are missing. Then let us just define two rules, link 1 and link 2. So we will call it link 1, it's probably link 2. So link 1 is actually this one, and the link 1 produces the output but doesn't use the dynamic linker, and doesn't link the startup code, and doesn't link the standard library and this thing as well. So this is the link 1, link 2. The linker is called here and here, so we write or let us actually add an additional variable that we will call link, and we will set it to the link 2 at first, and then we will include this variable in here, so just like this. And then we copy this thing from here, exactly, and say arguments path is path name new plus path name tname. This is actually wrong, I think. Yes, we need this stage path boot plus stage plus link arg. So actually we just want to add the state in here is directory, and then linker arg. If this thing exists, then we use the second linker, otherwise we use the first one. Okay, it is able to compile the whole thing. That works. I'm thinking how I can do these lines a bit shorter, probably define some intermediate variables. Or at least say that we have something like boot stage, and say that boot stage is actually build boot stage number. And valid stage, this is the same but with valid, and I can then replace this path with boot stage, boot stage, and boot stage. Then we can remove this thing here, and I can replace this one with valid stage, so we do actually the same. Exactly on the right side we have partly the same thing, so this would be valid stage, and this would be valid stage as well, and this would be the source, but this is a dependency from the bootstrap stage, so boot stage as well. These are different with the previous stage number. Yeah, these are actually pretty different, but this is boot stage then, and this one is boot stage. Yes, I think so. So let us test it once again. We remove the build ninja file, and we need to remove some stages. So there is the ninja log file. I cannot remove all of them since we do not build the first stage yet. So we just remove the 10th stage and everything above it with boot, and then I can try to compile it again. So break build.ninja, and then we just call the build system, so it still works as it seems. The build output is also a bit nicer out of the box. So this is done. This is done. And this is the first stage, so this should be written by hand. And we also compiled the first stage twice. So where do we put here? So first we need a rule in the beginning. So we already have a rule for the valid one compiler. I wonder if I can just use the assembler rule. So what do we want? We want a build statement. This build statement should compile I think build boot stage 1. Exactly, this is the first target. Build boot stage 1 compiler. For that, what does this compile procedure or function? It calls GCC with an additional nostdlib flag. So it does the compilation and linking in one step. We can actually add it as a rule. So we say that we have this CC rule and command GCC C flags plus nostdlib. Output is out and input. Then we can call this rule on the assembly file being this boot stage 1s. This is our input, and then we put a new line after that. And since it is a build statement, I want to put it after generating the rules. So here, this is the one, and the second step would be to generate the second stage. Of course, it is not assignment, but plus assignment. And we can just I need also a rule for this thing, because I want to use it here. So let us move this stuff. I'm not sure. I use this variable for this validation rules. So we just say that this is Ninja code, and it starts with a new line, and and ends after that. And then here we have a new line, and comment in out. After this rule, we want to have a boot rule of the same kind, so just boot 1, and this rule uses the Bootstrap compiler from the stage 1. We have already written a statement to compile the Bootstrap compiler, but we need a bit more in here. So we also define a multi-line compiler here, and we start it with a new line, and then we have a new line here. Boot stage 1 CL, and actually I think that we have to do pretty the same as what we do here to generate a validation stage compiler. So I'm going to copy this stuff in here, and here we have, so we generate the validation stage. It means that we write build valid 1 CL and build valid 1 and build valid 1 CL. The linker is link 1 comment, assembler is right. This is the previously generated file being valid 1, and here build valid 1 as well. Our source is not an ELNA file. No, it is not the source, it is the compiler. Our compiler is boot1 compiler from the previous build statement, which doesn't look like a build statement, and our source is the assembly file from the first state, and I think that it is not in any directory, so just called stage1s. And our dependency is the Bootstrap compiler, meaning it is boot stage 1 compiler. Something like this should it be. So we remove the previously generated build Ninja and the build directory as a whole. I think we do have the this valid and boot status. We do not need them. We can remove it. And just call rake build Ninja, and then Ninja itself. It says that build valid stage 1 CL is needed, but missing. Valid stage 1 CL. Valid stage 1 CL. Okay. I've written valid 1. Valid 1 is of course run. Valid stage 1, valid stage 1, valid stage 1. And now we can compile everything. So yes, I actually have a separate task. It depends on the last stage, and after that it does the comparison. I just can remove the dependency on the last task and it should work. So it actually needs the CLS. So actually, of course, we do not need to wait to save this stuff in a variable first. We can open the file right away and write into it. That would mean that we just say, was it F right? This is the header. Yes, it is how it is done, I think. Can I do it like this? Because it is actually what I need. So build Ninja and then rake build Ninja. Yes, that looks fine. And now we can change this the same way so that we write this stuff directly into the file. And then we go here, status H. that's it. So we do not have contents anymore. We just write these last lines. Well, okay, this is done, I think. So, as I said, I want to keep this task. We should just rename it, I think. It needs the source file of the last stage, so we still need the stages as global variable because it's used here. And it needs an assembly file. Yeah, the requirements are actually fine. This stuff is really used, but it won't be generated by Rake anymore. But these are kind of dependencies. Okay, that doesn't matter, but we do not need this stuff anymore, this rule. We do not need... this is object file compilation, we do not need this. Here we generate the stage compilation for each number. I think we do not need this loop as a whole anymore. So, and this is the stage 1. These directory are handled by Ninja now. We do not build the stage 1 here, so these rules can be removed and this rule can be removed, so that we only have this file task, and after that we have these documentation tasks. So this compile function probably isn't used anymore. We can get rid of it. This run function is used, I think, in here, but only once. We can just replace it, but well, it can be here. We have include and clean include, that's fine. Yeah, I think that is actually. So let us try it once again, so I can build Ninja file or generate this file. If this is generated, I can call Ninja, and then I can call Rake boot to do the final validation. So compare the output of the Bootstrap compiler with the validation stage compiler. That does work as well, and I think that is actually. The only problem that I do not want to have this Ninja build file into the root directory. I actually want to move it, change to dir before doing anything. Specify input build file, default build Ninja. It would be interesting how it works. So let us suppose that I generate this build Ninja file, not in the root directory, but in the build directory. So it is build Ninja. Build boot, build valid, global build. Oh, I also generate the documentation in the doc directory and not in the build directory isn't that good as well. I think everything should probably go into a single directory, but this is a task for a different day. So what we want, we have changed the target, so I can now remove that build ninja file, and then generate build ninja, and then I can call ninja with build ninja, and it does nothing. Let us remove the directory. Remove the directory, and then we need to generate that the file once again. And now, yeah, that works. I shouldn't change the relative paths in the generated file itself. Yeah. So I think this is finished. I should think how I can call, how I can make the ninja call a bit shorter, so that I do not have to specify the file path, the build ninja file path on the command line each time, but I can just define a shell alias or whatever. But actually we finished. So I already like the ninja output. It is a bit better because with Rake I have to print the commands manually, and it is that nice. And then when I continue to work on the compiler, then I will see if the performance is at least a little better than it was before. But for now, the translation and the change of the build system is finished, and I end the video here then.